In this example, you are asked to expand these functions in ascending power of t as far as the term t power of 3, and also determine the limits of t which the functions is valid. To solve this, you can rewrite the function here in the form of power of -1/2. From the function here, you know that the a will be equals to 1, the x will be equals to -2t, and the n will be equals to -1/2 in comparison to the formula here. This is the formula. Substitute the relevant value into the formula. You will get this. After simplifications, you get this. The expansions is valid when the x term here is less than 1 and greater than -1. This can be rewrite in the form of modulus 2t less than 1. After rearranging, you get modulus of t less than 1/2. These questions ask you to simplify these functions given the power of x above the first may be neglected. That means you are looking at the power of x only. The factors of greater powers, such as x power 2 and onwards, are neglected. You know that you can use this binomial theorem to solve the functions. This is the formula. You have 3 functions here. You will have to use the binomial series formulas for the 3 functions separately. And you only need to determine the term up to power of x only. Write down the functions one by one. Determine the a, x, and n from the function here. Adopt the relevant a, x, and n into the formulas. This will give you 3 terms. Next, you combine the 3 outcomes of the binomial expansions to be equate to the functions that you are interested. Solve the functions. You will get your final outcome. The function here has the power of x power 2 and 3. The questions said to neglect powers greater than power of 1. That means these 2 will be ignored. What is left over, it will be 1 minus 2x. Although the relationship between these 3 functions is in the form of multiplications and divisions. However, this term has already been rewritten in the form of power of -3. That means if this is being written in the power of -3, the relationship with the other 2 terms will also be in the form of multiplications. Therefore, the expanded outcome from this will add as a multiplications to the expansions of the other 2 functions. Let us try another example. You are asked to expand this as a power series as far as the term of x power 2. Next, you are asked to determine the range of the x which the series is convergent. This will be the formulas for the binomial series, and the functions which need to expand can be rewritten in the form of this, in the power of 1/2 and in the power of -1/3. This will give you two functions which require expansions by using the binomial series, which are this and this. You're going to expand them separately and also define their valid range. From the function here, you know that a is equals to 1, x is equals to 2x, and n is equals to 1 per 2. Substitute the relevant value into the formula, you will get this, and simplify it, you will get this. The valid range will be, this has to be more than -1 and less than 1, which can be written in the form of modulus 2x less than 1, where your modulus x will be less than 1 per 2. As for the second term here, the a will be equals to 1, the x will be equals to -3x, and the n will be equals to -1 per 3. Substitute this value into the formula, you will get this. After simplifications, you get this. The valid range will be modulus 3x has to be less than 1, which after rewriting, it will be less than 1 per 3. Now write down the functions which you need to expand, which can be rewrite in this form, in the form of multiplications. With that, their expansion here will also act as the multiplications relationship as calculated from here. Expand the functions and simplify it, you get this. For the term higher than power of 2 is neglected, as required by the question here, and based on the series of the valid range, modulus x less than 1 per 3 is more stringent. With that, the series is considered convergence for the range of the more stringent conditions.